Hello Zimbabwe, hello everyone around the world. Let's fix this laptop. This laptop is coming from a customer, and what the customer is saying the laptop just went off. This is Lenovo G50, right? So we have a switch here. Let's connect the power supply without wasting time. Because with the power supply we can see many things. That's the advantage of using a power supply. You can see many things like how much current is the board drawing. Do you have a shorted power rail? On Lenovo, I can go to 20 volts. I can go to 20 volts because this is a Lenovo. And this 20 volts. 3 amps. That should be fine. So plug in the power supply. It's taking on 190 200 milliamps. So based on the current, there you can see this current. If you see something like that, I can start the job, but the probability of having 19 volts and missing 3.3 is very high. Let's check out the battery and see if we still have that current. Without the battery, it's taking 4 milliamps. Now 200. Oh, 200. What is taking 200 on this motherboard? What do you think? We have the microcontroller, Lenovo startup chip. Yeah, it can be a fault 3.3 volts power supply. Like missing 3.3 volts power line. If I see something like this, I don't get surprised if my 19 volts is present and 3.3 is missing. Maybe this is just a waste of time because I don't have the controller for this motherboard. But you will see. We'll see what is taking that current. And it seems as if someone once worked inside this. We are now inside our laptop. So I'm curious to see where my 200 milliamps is going. Was it not normal to have such kind of a current when the laptop is off? Because when the laptop is off, the only power supply which will be on is the 3.3, the 19 volts and 3.3 always on. And for a laptop which is off, that current is too much. You must have around 10-15 milliamps standby current. So what is taking this power? Do you have 19? And we have 19. Exactly what I told you. Check there. 19 volts. I'm checking on the ceramic capacitors connected on the 19 volts power line. Check even here, 19. And the 3.3, we have the switch connector here. And we have 3.29. And the E.T.C chip, you can't even hold it. You can't. So these are some kind of waste of time. I'll unplug the power supply. I want you to pay attention to the E.T.C chip here. If I plug the charger, check here, the liquid is disappearing. So this chip is getting very hot. Maybe if I do like this. So exactly what I told you, that this kind of current will behave a dead controller. So the controller, the liquid is drying quickly soon as I plug the power supply. It is taking 184 milliamps. This controller is dead. The problem, I don't have this controller, so I will stop this video now. I will try to look for the controller and we'll do the second part. Okay? Hello everyone. Yeah, it's now 1 week later. I started this job 1 week ago. That was a Lenovo G50 motherboard. The laptop came in as no power, and I started this job like 1 week ago. And what did I found? What did I found? That the laptop, I started this job. I opened the laptop. Yeah, you can see here, I plugged in the laptop on power supply and was taking 205 milliamps. And I said, you know what, for a laptop which is not working, that's 205 milliamps is a lot. And I opened the laptop. I found the controller. You can see here. You can see this controller. I use isopropyl alcohol, and the controller was getting hot, and I couldn't find the controller. Now I came today to finish the job, because last week I couldn't find the controller, and someone sent me the controller. That's the controller here. So let me see if I was right or not. So we have to replace this big chip and see if this laptop will come back to life. But before that, let's just confirm to see if this motherboard is still behaving like what it was behaving before. Plug in the power supply. Now it's taking 80 milliamps. Let's unplug the charger. Still taking, now it's taking 80 milliamps. So all what we need to do, let's open the laptop and try to replace the E.T.C chip. All the screws are out. Let's try to take out the keyboard. keyboard out, touchpad connector, screen connector, and this one is supposed to come out. We have one more screw here. Network card out, and the top cover is the one which is coming out like this. Let's see the current that we have here. 3 amps. Let's plug in the power supply. Now it's taking 80 milliamps. Yeah, and the E.C chip is getting warm. Okay, so we don't want to re-diagnose this, but what I want to check before replacing this chip, because you know what, on the Lenovo laptop we have plus and minus. On the charging port we have plus and minus, and the middle pin, which is the charger ID pin. If you short the middle pin with plus, you burn the E.C chip. So let's take out the motherboard and check if the middle pin is not shorted to plus. I think that's all what you can check on this motherboard. Diode mode. This is plus. No, it's not shorted to plus, because if we replace the E.C chip and the plus is shorted to the middle pin, we'll burn again the SIO chip. So now let's replace this big chip. Let's replace this big chip. Can you replace this? Let's see what kind of chip is this. Lenovo E.T.C. Okay. Lenovo E.T.C. Okay. And our replacement is Lenovo E.T.C. So we order the right chip. So let's see how hard it can be to replace a big chip like this. So let's do it. That's the chip. You can see the chip is out. The chip is out. Now we need to clear the page. Let's make sure that all the pages they are properly. Let's take out that bridge. Now let's come up with the new chip. That's the chip that we received. So what the trick in replacing such kind of chip? What is the trick here? The trick, you have to resolder a few pins so that the chip won't move. So I'm just resoldering few pins. We do this so that the chip won't move. There are so many ways to replace this chip, but I want to do it on the beginner side so that everyone now all what you need is to put flags just like this. Now let's solder the chip. Now let's resolder this chip. We are coming with the hotel on the edges or where there are pins, not on top of the chip, but on the pins of the chip. the other side. We are trying just to simplify this repair, because it seems as if replacing the E.C chip is a big issue. Okay. Now we need to cool the chip. Let's cool the chip. With thermal pad. I'm using thermal pad to cool the chip. Now what is the next step? The next step is to verify if pins they have been soldered properly. We need to verify. If all these pins have been soldered properly. So I'm checking with a tweezer. This one is good. All these pins, they are solid. What about this side? All the pins look solid. All the pins look solid. So let's just wait for the chip to cool down, and then we can test. So it's that moment to see if we now have a working laptop or not. Yeah, the chip seems to be cool. Seems to be cool. Let's see. I need to check capacitors around this chip. Just to make sure that we have a good chip here. The capacitors looks fine. Let's see. Let's see. Let's see. And the middle pin with plus. The middle pin with plus. We have 2 pins on the plus, 2 on the minus, and the middle pin is not going to plus. So we need to connect the screen ribbon cable. That's what we need to connect here. Just to see. Okay. Yeah, the motherboard is supposed to be like this. Just a few screws to hold the motherboard. Okay. So do you think we now have a working laptop? Let's plug the power supply. Let's plug the power supply. It's taking 160, 124, 156, 192. We have change in current. Huh? And we have light here. You can see the light here. But it is light here. So don't have picture. Or I was trying to reload the settings. Huh? Let's see what voltage do we have here. What kind of voltage do we have on the screen connector? Zero. 3.19, 3.17. Okay. Let's reinsert the RAM. Let's make sure that the screen connector is properly inserted. And now, let's plug in the power supply again. That means the EC chip is working. If I see something like that, I know we have a working EC chip. Now let's try to power on with the tweezer. Pin number 1. Pin number 2 to ground. I can see the LED here. Now off, now on. It's restarting. Let's just wait. Maybe it's trying to reload the settings. So what's going on here? Huh? What's the story here? Coming on, goes off, coming on, goes off. With no picture. Huh? Let's unplug here. Let's try one more time. Charger plugged and it's taking 24 milliamps, which is standby current. Let me try to shoot pins one by one. Pin number 1, note number 2, number 3. Pin number 4 to ground. And the laptop is working. Yeah? Check the current. It's now taking 326 milliamps, 325 milliamps. So why the laptop was taking too long to light? You know, when you change the E.T.C chip, it's trying to reload the settings, reprogram the E.T.C chip. But this is some kind of, I think it's the one with BIOS inside, because I can't see the BIOS chip here. But on this one, it's a pre-programmed. The chip just programmed itself. So that's why it was taking too long to power on. The laptop is working fine. So, what was the problem? That was the problem. Dead E.T.C chip. You can see this chip. So, I feel so good when I see something like this, because we do the right diagnosis from the beginning. The laptop was taking 200 milliamps, and it was off, and the E.T.C chip was getting hot. Now everything is working fine. I can power off the laptop. Let's power on. I think it's pin number 3 or 4 to ground. Pin number 4 to ground. And the laptop is working fine. So I'll stop this video now. Like, subscribe. Don't forget to turn on the notification bell for future updates. And see you on the next one. That is how you can replace a dead E.T.C chip. See you on the next one. Bye.